Right, good afternoon. My name's Helen Johnson. I was one of the senior markers on questions 17, 18, 24 and 25. Question 17 was the integral involving the logarithm. The positives for the question was that it was generally well done, the state average being 1.45 out of 2. Most students recognised that this question involved integration using logarithms. Most students knew to rearrange the expression into form f-x over fx and then add a constant to compensate for the change in the numerator. If they had done this, most students then correctly integrated the expression. The negatives of the question were that some people couldn't incorrectly adjust the fraction for the numerator and the denominator. They knew that 2x went on the top, but they forgot that a lot of them put 2 outside the integral sign instead of a half. Some students, when they integrated, didn't use brackets, so they just had log and then 4 plus x squared, and you had to have brackets or absolute value signs. There was a bit of confusion as to whether it was log to the base 10 or log to the base e, but basically if you indicated it was log, we're assuming that you knew what was right. There were many students that didn't add the constant after integration. They should be encouraged to do this, because if the question requires anything else, they won't get the correct answer. The learning outcomes were, please encourage students to use the reference sheet provided and encourage students to show working and to not give a bald answer, because as this was a 2-mark question, if you had an incorrect bald answer and it was all wrong, you couldn't access the 1 mark. Question 18 was a differentiation that involved a product rule with an exponential expression and a binomial in brackets. This was generally well done. The state average is 1.72 out of 2. Most students recognised that this question involved the use of the product rule and successfully found the derivative. The more successful students did label the 2 terms u and v before using the product rule. The negatives: many students did not use brackets around the expression 2x plus 1 when they applied the product rule. There were some students who could not correctly differentiate e to the 2x. They put 2x e to the 2x, x e to the 2x, a half e to the 2x. There were a lot of variations. This was a question that normally we tell our students that they don't need to factorise after they differentiate. But here, if you hadn't read part B of the question before attempting part A, you didn't realise that you really needed to fully factorise your answer to be able to access the mark for part B. And this presented a major problem. The learning outcomes: again, students should be encouraged to consult the reference sheet for all integration and differentiation questions. And students should be encouraged to read the whole question if it involves more than one part before attempting the first part. 18B, this was a 1-mark question. It was successful students identified that hence required the use of the previous part to actually be able to find the integral. Able students then manipulated the previous answer to enable them to work backwards and to correctly find the integral. This question was not that well done. State average was only 0.4 out of 1. Because a lot of students did not attempt to or incorrectly factorise part A, they then didn't see the link between the 2 parts of the question. So in actual fact, many students made no attempt at an answer at all. Some students who did actually correctly factorise part A couldn't manipulate that previous answer to enable them to work backwards. and then correctly find the integral. The learning outcomes. Students need to automatically recognise that the word hence requires the use of a previous part to answer this section. Students also need to understand that a 1-mark question generally requires just a simple step to get to the answer. And in this case, it would have been helpful for students who were nearly on the mark but not quite there to just check their answer by differentiating what they got, and they might have realised that they had the wrong constant. So basically not a very well done question because people didn't realise they were linked. Question 24 was an expression given for a circle, an algebraic expression, and they wanted to reflect it in the x-axis. Students needed to be careful here of the wording of the question. It said, sketch the reflected circle showing the coordinates of the centre and the radius. The positives were that most students realised that this question involved completing the square to transform the equation into one from which they could determine both the centre and the radius of the circle. Successful students generally applied one of two methods. One was they completed the square and found the centre and the radius of the original circle, stated it was the original circle, sketched it, then reflected it in the x-axis, clearly showing which was their answer. The more abler students replaced y with minus y in the original equation, completed the square, and then just sketched a single circle showing the radius and the centre. Nearly all students who had a circle, whether it be the correct or the incorrect one, could correctly reflect it in the x-axis, so they could access some marks. The negatives. This was not well done generally, the average being just under 50%, 1.45 out of 3. There were many students who couldn't complete the square successfully. The main errors were that they'd have 2 brackets with squares on them and no sign in the middle. Some students had a negative sign in the middle. Some students had incorrect signs in the brackets, so their centre and radius weren't in the right spot. And there were many students who had r squared, a negative number. Some students who did successfully complete the square couldn't state the centre and radius. They gave the wrong signs. Some students did not recognise that when they got a radius squared being negative on the right-hand side, they must have made a mistake when they were completing the square, and they never went back to have a look to see where they'd made the error. When sketching the circle, students needed to show some degree of accuracy. In other words, they needed to show what quadrants the circle would lie in. The x and y intercepts weren't necessary, and many did not show them. There were quite a few students who completely put the circle wholly in the first quadrant, which unfortunately was not correct. So we need to tell our students that they need to have some kind of scale on their diagram. There were some students where it was difficult to tell which was their original circle and which was their reflected circle if they only gave a graph as an answer. In other words, there was no sign of working involving completing the square. So in this case, they should have really indicated which was their original and which was their reflected. And of course, some students reflected in the y-axis instead of the x-axis. Students really should have stated what the centre and radius of the original circle was, so that the marker would have known what the reflected circle was. In some cases, there were 2 circles, but we never knew what the original centre and radius was. Learning outcomes. Students need to be ensure that they can complete the square successfully. They need to be able to sketch circles clearly when the centre is not the origin. They need to use a reference sheet if they're not sure to check they have the correct form for completing the square for a circle. Question 25. This was a 7-mark question, and different parts were done to a different degrees of ability. More people got marks in part B than they did in part A. Part A was a 3-marker, and it was a show that question. The positives were that most students did understand what the question required. Good students were able to use correct area and perimeter formulae for familiar shapes and establish the correct algebraic expressions needed to find the perimeter P. Most students then attempted to rearrange their expression for the area to make y the subject of their equation and then substitute this into their expression for P. Good students could then simplify their expression for P into the form required. Interestingly enough, quite a few students got an expression for P in terms of X, but it was not the one requested in the question. Negatives, again, this was slightly below 50% getting half marks. The state average was only 1.4 out of 3. There were many students who did not know the correct formulae for the area and circumference of a quadrant of a circle. There were some students that did not realise that the radius of the quadrant was X. Another major problem was that many students forgot to add X to their perimeter. They just put the arc length of the quadrant of the circle and forgot to add the extra X. Most students realised that they needed to use the area formula to help substitute for Y, but there were quite a few students who couldn't correctly make Y the subject of that area expression. In particular, most made XY the subject, which was the best step, but when they divided it by X, they often only divided one of the terms on the right-hand side by X, which meant they were never going to get to the answer. Once some students did successfully make Y the subject, and there were many variations that were acceptable, but then they could not show how they used that to get the final simplification for P. And as this was a show that question, some students skipped important steps that you needed to show to get full marks. The most common step skipped was the one where you had to expand the brackets for the substitution of Y and then simplify the expression. Learning outcomes. Students need to be able to manipulate expressions involving complex algebraic fractions. Over the years that I've been a senior marker, this has been a recurrent problem. Students cannot add and subtract complex algebraic fractions easily. Students should also be clear on what detail the show that question implies. In other words, basically don't leave any steps out. And students need to know relevant area and perimeter formulae that are often used in maximum and minimum problems. The final section here, 25B, was find the smallest possible perimeter of the garden bed, showing why this is the minimum perimeter. And we can all give ourselves a pat on the back. There were many students who could not successfully do part A and then successfully got full marks for part B. The positives was that generally it was well done. State average 2.2 out of 4. Most students knew what steps were required to solve a maximum and minimum problem. They saw that it was 4 marks. They knew that there was probably a minimum 4 steps. And as I said before, many students who couldn't do Part A did obtain full marks in Part B. Most students could successfully find the first and second derivatives of P and then go on to solve P dash equals naught. Most students could verify a minimum P at their X using either the first or the second derivative test. Most students then successfully found the minimum perimeter which was required. The negatives, and there were quite a few for this question. Some students could not change 72 over X to 72x to the minus 1 in order to find its derivative. There were many students here that used the quotient rule successfully to find the derivative of 72 over X, which is fine. There are a significant number of students that integrated instead of differentiating. So they gave their answer as 2x minus log 72 log x. They did successfully go on then to find maximum and minimum and could be awarded some marks. Some students could not solve P dash equals naught because there was an algebraic fraction involved, which comes back to our problem that seems to be recurring involving any manipulations with algebraic fractions. When testing for a minimum P using the second derivative test, some students were confused as to what a positive or negative answer meant. So we had some students saying if the second derivative was greater than naught, it was a minimum, the second derivative was less than naught, it's a maximum, and so on. If you're using a table of values and you're going to give your answer as plus and minus and 0 in the middle, students need to clearly state what they are testing using either the first or second derivative, because if you have a plus or a minus and you don't indicate, we have no idea what test you have used. Students should also avoid using forward slash, dash and backward slash to show the signs of the first or second derivative in tables of values. Numerical answers are better. When you use the second derivative test for verifying a minimum, substitutions should be shown. So not just f double dash x or p double dash x is greater than naught, therefore whatever. No, you need to actually show us you substituted some value for x. Some students here carelessly got a negative answer for x, which obviously you can't have a negative length. And again, this didn't ring alarm bells for them, and they did not go back to check where their error occurred, and it was often just a simple numerical mistake moving something to the other side of an equation. And unfortunately, some students did all the derivatives and the testing successfully, but they forgot that the question said this time that you were required to actually find the minimum value of P. So that was an easy mark that not a majority, but a minority of students who got it all right forgot to keep going. Learning outcomes. Students need to be aware that a 4-mark question would normally have a minimum of 4 steps of working. We had some students here substituting in numerical values and just guessing what the answer, some of them fluked what the value of x would be. Students need to be adept in differentiating terms with algebraic fractions involving x in the denominator. And students need to carefully read the question to ensure that they answer all that is required to obtain full marks.